Hi, we want to find the potential function, continue from the previous video. So from previous video, we understand that if a vector field is conservative, it is equal to the partial derivative of the small f. Actually, this small f itself is the potential function, and because some book they use this symbol, yeah. So in order to find this small f, that means we just directly integrate the vector field given, and we get small f. Okay. So we continue from the previous example, example 1. So given the vector field, and this thing, the vector field, we already proved that from last video, is conservative, means it's just equal to the small change of the f, the potential difference, potential function. So, and we just straight away say that we integrate this to get potential function. So the fx, this part is on the x, is already partial derivative, is so in order for us to get f itself, so this is already partial derivative in respect to x, because based on the definition, function is equal to the small derivative. So this is the small derivative of x, this is small derivative of y. And in order to find f, we have to integrate this one in respect to dx. We have to integrate this whole thing in order to get dx. And we do the same for fy dy. So fy is this, then we integrate in respect to dy in order for us to get the potential function, or sometimes it's in this symbol. It's the same. Okay, so let's get started. So we do all integrate the fx first. So okay. So x cubed, so x 3 plus 1 is 4 divided by 4. So 4 and 4 cancel up, so no more 4 here. Y cubed plus 3x. So since this is if we differentiate in respect to x, then we should have something or a function in terms of y, but it doesn't have x. But it's just in y, but if we differentiate, we actually is constant, that will be vanished. But right now we integrate back, we have to add back a function in terms of y, because you can try to verify yourself. If you do again partial differentiate of this whole thing, the function of it y will be cancelled off, become nothing, so we get back the same thing. So here we need to add it back. Later I'll show you why we did add this. Okay, so we do the next part for partial derivative of y dy. Okay, so y cube and divided by 3. Here got 3, cancel it out. So 4 plus y plus a function in terms of x. Okay. And as we know this is the potential function, is also the potential function, but there's just slightly some difference between them. So in order for us to get the potential function, okay, that's a potential function. So we just, these two are the same, we just copy one time, then don't repeat. Okay, just have 1 3x, so I write it down. Actually, this 3x is the dx of this one. And then we have 1y, we copy down. Okay, and this y actually is this fy. All right, so we copy down the thing that is different. And after we integrate, we need to add something, which is a constant as normal, because we differentiate a number, we get 0 as well. So we need to add a c here to a constant. Therefore, this is the potential function. Or you can say, instead of using the small f, you can put this one is in terms of this. Let's look at another example, which is number 3. Because example 2 is not conservative, so therefore there's no potential function. Right? So we do the same thing. This part is equal to fx, this part equal to fy, this part is equal to our fz, because f is equal to the small derivative of small y. And this thing is actually means the df, the partial of x, partial of y, partial of z. Actually, this inverted triangle means. Okay. In order to get f, then we integrate this one, dx to get f, integrate this one to get f, integrate this one to get f as well, and then we compare. We just copy down the term that is that just appear differently. Okay, let's get started. Partial integrate y plus yz in respect to x, and we should get xy plus xyz, and then plus, because we have the function in terms of the opposite, which is the y and z as well. Okay, because a function or a term with yz but doesn't have x, we partial differentiate it in respect to x, we should get this one eliminated. If we reverse it back, you should get back the same thing to prove it. Okay, and next, so in terms of y, so x times y, xy plus 3y z cubed plus xyz, okay, and add a function which doesn't have the y, so this is xz. Okay. And continue. Next, dz. So z here the square, then z squared plus 1 is z cubed divided by 3, so we got 3z cubed here plus x, y, and z minus z plus the function of xy. Okay. Therefore, these all three are the potential function. Repeated and no need to copy. Just copy once if repeated. So we can say f, or I put this one. Okay. So xy appear 1, so I put xy, xyz plus xyz. So those who have xyz I can set up. And here plus 3y z cubed. Okay, 3y z cubed. And then minus z. Okay. And then the rest will be nothing but just a constant. And that's it. For us to find the potential function is quite straightforward. I mean, the step is not so complicated, but you just need to remember the method on how to find the potential function. All right, see you.